Here we are with Simpson's rule. This is section 5.5, part 2, or B. Again, we're talking about another approximation method. So if we have an integral and we want to approximate it, we can use Simpson's rule, given as s is equal to h over 3 of y sub naught plus 4y sub 1 plus 2y sub 2 plus 4y sub 3 plus etc. plus 2y sub n minus 2 plus 4y sub n minus 1 plus y sub n, where the interval a to b inclusive is partitioned into an even, notice even is important, number of n subintervals of equal length, which we can find by using the formula h is equal to b minus a over n. Key here, there's an even number of intervals, which means we will have an odd number of data points. We need to keep this in mind for Simpson's rule. Let's look at an example. Another approximation method. Example 1. Dun dun dun. Use Simpson's rule to approximate the integral from 1 to 2 of 5 over x dx when n is equal to 4. So the first thing is, let's write a is 1, b is 2. Let's calculate h, since we know it's going to be 2 minus 1 over 4, which is 1/4. So far, so good, right? If this is the case, we have 4 intervals, which means we'll have 5 data points between 1 and 2. So again, we're going to have little x, little y. We're going to start at 1. That's 2, that's 3, that's 4. And we're going to finish with 2 at 5. So if we divide this up equally, hopefully you guys can see 1.25, 1.5, 1.75, so that we have 5 data points and 4 intervals, each equal to 1/4, 1/4. All right, now we're going to solve for our y values. Remember, these are our y values. When we plug 1 into the actual function, hopefully you see we get 5. Then we're going to get 4. We're going to get 10/3. We're going to get 20/7. And we're going to get 5/2. Hopefully this is good. Next, we're going to fill out our formula. So we have s sub 4 is equal to 1/4 over 3 times key. Start off with 4, alternate, then there's another 4, and we're going to alternate with 2's. Notice we're going to start with a 4, we're going to end with a 4 right before our initial and last y values that are not multiplied or changed by anything. So if we look at this, we should get 1/12 of 5 plus 16 plus 20/3 plus 80/7 plus 5/2. This is equal to 1/12 of the quantity 1747 over 42, which is equal to 1747 over 504, or 3.4663, depending on what I'm asking you. Now again, just like with the trapezoidal rule, I may ask you to calculate the percent error. For calculating the percent error, we still need to remember the formula for percent error. That it's actual minus estimated absolute value over actual times 100%. So we need to calculate the actual value of our integral. So the actual rounded to the nearest fourth decimal place, or 10,000, 3.4657. So when we calculate our percent error, we should get 0.017%. We did a fantastic job, and this is Simpson's rule.